In 26100, when I lectured Newtonian mechanics, I demonstrated that the period that this pendulum produces is extremely close within the error of measurement what you predict. In other words, the mass of the string is indeed negligibly small compared to the mass of the object. We weighed the string once, I don't remember what it was, but it was such a small fraction of m that indeed could be ignored. And so the prediction then is, if you simply put this L in there, T predicted, purely on the basis of that simple equation, equals 4.57 plus or minus 0.02 seconds. And this 0.02 is the result of this 0.05. There's a 1% error in here, right? 5 out of 518 is 1%. And so the error in T is 0.5% because it's the square root. And so you get a 0.5% error. And I rounded that off. So that is the prediction. And then I made two measurements, one at 5-degree angle and one at 10-degree angle, and I did that 10 times. So 10t at 5 degrees and 10t at 10 degrees. Now this was in 1999. Those were my good days. They were my good times, right? The past is always the good. And so I then claimed that I could do this to an accuracy of 0.1 second. I had a lot of courage in those days. And I measured the 5-degree, and what did I find? Unbelievable. Truly unbelievable. Purely lucky. I found exactly that number, which of course is an accident, because my accuracy was no better than 0.1 seconds. And then I did it at a 10-degree angle, and then I found this. And so I demonstrated that indeed 5 and 10 degrees are still considered small angles for that approximation. And it is within the uncertainty of my measurement what you expect. Then I wanted to demonstrate, which is not so intuitive, that the period is independent of mass, which is not the case for the spring. So now if you change the mass and you don't change L, you expect no change in period. And that's what I really wanted to show you here, but I can't. And therefore I've decided to show you what I did in 1999. If you can show us that 2-minute version of my video lectures, then you can judge for yourself to what extent the mass does not influence the One of the most remarkable things I just mentioned to you is that the period of the oscillations is independent of the mass of the object. That would mean if I join the bob and I swing down with the bob, that you should get that same period. Or should you not? I'm asking you a question before we do this awful experiment. Would the period come out to be the same or not? Some of you think it's the same. Have you thought about it? That I'm a little bit taller than this object, and that therefore maybe effectively the length of the string has become a little less if I sit up like this. And if the length of the string is a little less, the period would be a little shorter. Yeah? Be prepared for that. On the other hand, I'm also well, I'm not quite prepared for it. I will try to hold my body as horizontal as I possibly can in order to be at the same level as the bob. I will start when I come to a halt here. There we go. Now, you count. This hurts. Ah. I want to hear you loud. Oh. Thank you. Oh. T with Walter Lewin. 45.6 plus or minus 0.1 seconds. Physics works, I'm telling you.